Hello class, this is Mr. Rindle. This is our first go round with looking at some lessons from the Trig book. All the sections of the book will be on the first slide, so this is section 1.1. I'm hoping that this is a lot of review pieces. I'm not planning to go over every single detail of every question because a lot of them are similar, or at least there's things written down that should be easy to find. I do plan on highlighting a few things and making sure they're on the right track though. So like I said, this is about angles. The first thing that you want to look at is what's known as a positive angle versus a negative angle. So positive angles always go counterclockwise, and they're kind of always from this like sideways from the x-axis. Sorry, wrong arm here. So sideways from going to the positive x-axis and then kind of going around in a counterclockwise manner. Negative angles go the opposite way, so they'll go down and around. Okay, that's the difference between a positive and negative angle. So every angle, though, starts with that same positive axis side. Circles 360 degrees. There's not necessarily a rhyme or reason for that. The best guess is because before calculators, you would have to divide by a lot of numbers, and 360 has a lot of factors. So that's just some info about why a circle is 360 degrees. You'll be asked some things about complementary angles and supplementary angles. Remember, complementary are two angles that add to 90 degrees. Supplementary is two angles that add to 180 degrees. So you'll have questions that maybe look like this one, where it's just find the measure of the each marked angle. So I put this in kind of a specific way for a reason. Make sure you answer the question. So what I've written here is x is 7, but remember the angle then, you'd have to plug back in the x value to figure out what the angles are. So keep that in mind in questions like this as you're looking at them. These two are supplementary angles because they add up to 180 degrees, so you add those two things together and set it equal to 180, and then see what you get for a solution. The next thing I want to talk about is degrees, minutes, and seconds. That idea is important when it comes to things in word problems, things in trajectory, for example. Essentially, you have degrees, and then you have parts of a degree, which is called a minute, which is the one with a tick mark, and then you have a second, which is 1/60th of that. So really, the idea is it's kind of like a place value. So if you have a degree and you want a partial degree, it's divided by 60. If you want a partial minute, it's divided by 60 again. So that's where those pieces would come into play. So I have examples going in both directions. If you're trying to convert from a degrees, minutes, seconds, so if you look, it's 25 degrees, 40 with the one tick mark is minutes, and then 30 with two tick marks is seconds. And so all I'm doing is splitting that up. The 25 should be 25. That part should be the same. The minute should be 40 out of 60, and then the second should be 30 out of 3600, or 60 times itself, or 60 to the second power. And all I'm doing is multiplying all that together. And in this case, it worked out nicely. I would encourage you to try these out, making sure that you can get the answer correct using your calculator. So just typing that in and making sure you get to the right answer should be helpful for you. Going the other direction, if you're trying to convert from a degree decimal to degrees, minutes, seconds, the key is you split up piece by piece. So 36 degrees is 36 degrees no matter what. Okay, there's no way that's going to change as you're looking at that question. So 36 degrees, you'll notice, is at the last part of the question. Then you have to move to the 0.871. That 0.871 is you have to take it times 60 because you're going backwards from what you did before. So if that's the case, you have to take 0.871 times 60, and that'll give you 52.26 minutes. From there, you have to kind of do that idea again. So you have to take the decimal part by itself and then do the same thing. And then it says to round to the nearest second. Some may say to round to the nearest 10 seconds. It kind of depends on what you're looking at. But in general, you want to try to find the solutions from that question based upon divide or kind of separating out and then times 60, separate it out, times 60 again. Evaluating is pretty simple. It's just like place value in terms of like add the tens place, add the ones place. So for this question, you'd add the degrees. So take 132 plus 120 and take 18 plus the 53. You'll get 152 degrees in 71 minutes. The issue is you can't have the minutes be higher than 60. And so if that's the case, you have to kind of take one out from it and add it into the other group. And that makes it kind of like a borrowing technique, or if you add up and carry the number So that's the same idea there. The second one is a subtraction problem, so you'll notice that I borrowed. So I borrowed 1 from the 90 and made it 89. And then taking out 60, because 1 degree is the same as 60 minutes. And so I just change that back, and then that's how you get the 71. So I'm just taking 1 degree away, making it 89, and then taking 60 into it, because each degree is 60 minutes. And then you just subtract the degrees, subtract the minutes, and that's how you find your answer. I would probably write this slide down somewhere and have it as a reference. I think it's going to be helpful for you as we kind of move forward with some of these questions. Remember, the initial side was always that positive x-axis. And then if it goes counterclockwise, you'll notice that straight up and down is 90 degrees, to the left is 180, and straight down is 270. And that correlates, the reason that it goes that way is it correlates with the quadrants. So you'll notice I put it in quadrant 1s, 2, 3, and 4. The terminal side is always where it ends up. Okay, so the terminal side is where that angle would end up. So what's going to happen here is that you have what are known as coterminal angles. Now, coterminal angles mean they start and end at the same spot. So if you look at my picture here, they both start at the same location to the right on the x-axis. A goes in the positive direction, B goes in the negative direction. They get to the same spot. The idea is there's a fast way to get somewhere and a long way to get somewhere. So for example, if I've noticed that when I go certain places with my mom, for example, she takes a certain route to get to a store. I'm going to take a different route, and I say, Mom, why don't you take that other route? It's way faster to take this route. And she said, I don't care. I'm taking this route. I've taken it for years. This is the one I'm doing. I say, okay, no problem. And so we have 2 different ways of getting to the same place. It's just that we took a different route to get there. That's what it means by coterminal. They start in the same spot, end at the same spot as you're looking at the angles. Okay, so the next thing that we want to look at is just finding angle measurements that are coterminal. So what I have started with is negative 50 degrees as an angle. So you'll notice in blue there I drew negative 50 degrees. I start at this positive x-axis. I go downward because negative angles go clockwise. And negative 50 is in that quadrant because it's not 90 yet. The sooner you can figure out what quadrant you're in, that's what's important. Don't worry about the measurement being perfect, but you need to figure out what quadrant it's in. And so the idea here is if you want a positive angle that's the same, just go the other direction. Okay? And if you think about a big circle, it's 360. And so if this part's 50, you say, well, 360 minus 50 is 310, and that's where the answer comes from. On the second one, you'll notice that I kind of have this curly Q or the spiral going around. Each spiral is 360. And so I went 1 time around for 360, 2 times around for 720, and that's what that minus 360 on the side is saying. And then I'm left with the same as 25 degrees. Okay, so that's this piece and up a little bit for 25. So when you're finding some angle that's coterminal, that's kind of where you want to start with. I think the last one we'll look at for today's lesson deals with angles and generalizing what they look like. So for this question, it just says write a general idea for the angles. What you want is that angle, and basically take a curly Q around. Go around, go around, go around, go around, do a lap, do a lap, do a lap. And that's just add 360 a bunch of times, or subtract 360 by going backwards. And if that's the case, what you're looking at then is just 110 plus 360 times n, where an n is an integer. You don't have to worry about plus or minus in the question as long as you say n is an integer because it solves that for itself. Okay, so that gives you an intro to angles. We'll finish up this on Monday and keep moving forward. You want to make sure you keep working on the Math Excel homework. It should be posted now, homework 1. That's going to be due Tuesday night at 11:59 p.m. with an assessment of the first couple lessons on Wednesday. So that's going to be our plan. It's probably going to be a smaller chunk just because it's early in the semester, but as we move forward, I think that will increase a little bit. So make sure that you've written some few notes down. Keep track of things to make sure you know where they're at, and hopefully that will go okay for you as we move into the weekend. Have a good day, everyone.